All right, last but not least is the baby rational functions. These are the reciprocal functions. So like 1 over x, 1 over x squared, 1 over x cubed. And I have these typed different ways on purpose. So this is the same as an x to the -1, an x to the -2. This one could be written as 1 over x cubed. So just to recognize that the negative powers give you the reciprocal functions. And it's called reciprocal because that's what 1 over is. It's a reciprocal if you take 1 over something. So these are the reciprocal functions, which give us the beginnings of our understanding of rational functions that we'll really get focused on in 142. So I just have a few of these showing, and I'm starting with quadrant 1 again. Notice there's some interesting behavior. The graphs are getting really, really steep near the y-axis and really, really flat near the x-axis. This is called asymptotic behavior, and this is the first group of functions that we looked at that has that asymptotic behavior going on. So asymptotic behavior means the graph has an asymptote. And this one has an asymptote at the x equals 0, the y-axis, and another one at y equals 0, the x-axis. We could even type those in, x equals 0 and y equals 0. And if you're graphing these on paper, what you'd normally do is show that with a dashed line. So we show that there's an asymptote by making a dashed line. You can kind of see those sitting along the axis. And that just shows it's not really part of the graph, but it's governing the shape of the graph. So basically with asymptotes, your graph is going to get infinitely close to that. With horizontal asymptotes, so that's here a horizontal line that the graph gets close to, you actually could cross those. So this graph does not, none of these graphs do, they get infinitely close but don't cross, but there's no rule about that. A horizontal asymptote is just a global behavior. It's back to that whole idea, as x approaches infinity, y approaches 0. If you can say something like that, it's a horizontal asymptote. It could also be y approaches 1 or 2 or 7, whatever it is. There's no reason that a graph couldn't cross below and then come back up above and down below. As long as it's getting closer and closer to 0, it still counts. The vertical asymptote, even though it's kind of a similar idea, it's happening for a different reason. We're getting the vertical asymptote because notice in this function, you can't plug 0 in. So there's actually a domain problem or a discontinuity there. The function is not continuous. It jumps over. We can, however, plug in very, very small positive or negative x values. And if we plug in a very small positive x value, the reciprocal of a tiny number is a huge number. And the smaller that number you plug in, the bigger its reciprocal will be. So as close as we want to get to the y-axis, we can get a y value. It's just going to get bigger and bigger and bigger in a crazy fast way. And that's what's causing the vertical asymptote. I'm going to go ahead and show the other side now. Note that for our 1 over x, if we plug in very small negative numbers, their reciprocals are very big negative numbers. So it actually goes opposite directions. So asymptotic behavior, and I'm going to turn some of these off. Let's see. There's your 1 over x, your 1 over x squared. So these two go on your parent function chart. Once again, notice they go through 1, 1, and then they'll either go through negative 1, 1. It won't let me click on it. There it is. Or negative 1, negative 1, which I almost hit. So put those two down. We do have some interesting symmetry here, and we'll look at some more powers and I'll mention that more, but those are going to be parent functions that we're going to use and rearrange and practice some graphing with. Okay, so let's turn on the odd powers. Turn off squared. Okay, so notice that all the odd powers have sections in quadrant 1 and quadrant 3. They all again show the odd symmetry, so that's sort of interesting. We see similar things to the other sets where, let's go back to quadrant 1 here. Between 0 and 1, we'll see certain functions have the smallest y values, and then for bigger x values, it'll flip-flop, and those ones will then have the biggest y values. So we see that kind of interesting flip-flop happen at 1, 1. Otherwise, there's our odd power functions, And there are our even power functions. Oops, almost. So even symmetry for the even powers on these reciprocals. Every single one has the vertical asymptote at y equals 0, the horizontal asymptote at x equals 0. And if you're drawing these by hand, make sure that you include those dashed lines so that I know that you know that those are there. Okay, so final group of functions that we want to be familiar with. So in this section, we're going to focus a lot on quadrant 1, but as we move on in the quarter, we're going to be paying attention to what's going on the other side as well.